This video is about triangle inequalities. Let's take a look at some notes on triangle inequalities. There's something called the triangle parts relationship theorem, which basically says if you're looking at one triangle, if the side is bigger, then the opposite angle is bigger. So it's all about comparing sides and angles. So for example, I see that 16 is the biggest side. That means 88 would be the biggest angle. Even if I couldn't see the angles, I would know that angle A is the biggest angle. So the biggest angle and the biggest side are always across from each other. That's really what both of these theorems are saying. So looking back at this problem, alright, so the bigger side will be across from the bigger angle. Since angle B is the largest angle, okay, let me get my marker ready. Since angle B is the largest angle, then AC should be the longest side. Alright, so it's as simple as that. Now, based on the given angle measures, which triangle has the side length measures that could be correct? So basically, we're going to look and see, are the biggest sides across from the biggest angles? Okay, so let's see. The biggest angle, for the first triangle, the biggest angle is 90 degrees. Alright? The smallest angle is 30 degrees. And the medium-sized angle is 60 degrees. So this is sort of the order of the angles. So now let's look at the sides that are across from them. So the 90-degree angle is across from the 16.1. The smallest angle, 30 degrees, is across from the 14. And then the 60-degree angle is across from the 8. So since we have the angles in order from greatest to smallest, if this is a proper triangle, then the side lengths should be in order from greatest to smallest. And you see that these two are out of order, so this cannot be the answer. Alright, let's look at the next triangle. Again, we've got the 90 and the 60 and the 30. Alright, across from the 90 is the 14. Across from the 60 is the 8. Across from the 30 is the 16.1. These should be in order from biggest to smallest, just like the angles. Clearly they are not. Got the biggest side is across from the smallest angle. That's nonsense. So that can't be the answer either. Let's look at the next one. Okay, so again we have the 90, the 60, and the 30. Let's check the sides. Across from the 90 we've got the 14. Across from the 60 we've got the 16.1, and across from the 30 we've got the 8. Okay, these are out of order. So since we do not have biggest to smallest like the angles are, then this is not a proper triangle. So we're down to the last choice, so I'm really hoping this is going to be the answer. So once again, 90, 60, 30, biggest to smallest. If this is a proper triangle, the side lengths should be biggest to smallest. So across from the 90, we have 16.1. Across from the 60, we have 14. And across from the 30, we have 8. And finally, we see that the side lengths are also in order from biggest to smallest. So this is a proper triangle. So that means this last one should be the answer. And there you go. Let's see, we have these two triangles. Alright, it looks like we're setting up to use something called the hinge theorem. Okay, let me look at the notes here. The hinge theorem says that if you have two sides in one triangle that are congruent to two sides of another triangle, the angle, if the angle is bigger, then the opposite side will be bigger. So I see the 52 degrees is bigger than 40. That means FE would be bigger than CB. So that's called the hinge theorem. Okay, so I see this could be the hinge theorem because we have these two sides are congruent to these two sides. So if angle S is bigger than angle C, that would mean that RT is bigger than BA. Okay, so we're talking about the angles and the sides. So let's see. RT is greater than BA. So which statement is true? So they're telling us that RT is bigger than BA. For example, maybe RT is 10 and BA is 8. So they're giving us that. All right, so that tells us that since RT is bigger, then that means that angle S must be bigger than angle C. Okay, S is bigger than C. Okay, I'll just say it in words. All right, so I just mentioned the hinge theorem. So look, you've got the hinge theorem and you've got the converse of the hinge theorem. They almost say the same thing. The only thing that's different is if you're talking about the hinge theorem, let's see if I can write on this. In the original hinge theorem, you're given the angles and then you're talking about the sides. Okay, so in the original hinge theorem, oh no, my pen is crashing. Okay, in the original hinge theorem, a bigger angle means a bigger side. All right, so that's the original hinge theorem. Now, in the converse, you're starting with the sides, and then you're asking about the angles. So in the converse, it would go like this. Bigger side is going to be across from the bigger angle. Okay, so if we know the angles are bigger, it'll be the original hinge theorem. If we know that the side is bigger, if we know which side is bigger, then it'll be the converse. So looking at this example, they gave us the side, okay, first. So that means it's the converse of the hinge theorem. So by the converse of the hinge theorem, we know that angle S is bigger than C. So this says by the converse of the hinge theorem, C is equal to S. No, they're not going to be equal, so this is false. By the hinge theorem, well, it's not going to be hinge theorem, it's going to be the converse. Okay, so we can forget about that. By the converse of the hinge theorem, angle C is greater than by the converse of the hinge theorem, angle S is greater than angle C. And that's what we just decided. So this one right here should be the answer. Okay. If NP is greater than MP, so this is going to be another hinge theorem because we have these sides are congruent. This would be the hinge angle right here. Okay, I'll just put a big blob there. And then we have these two sides are congruent. All right, so I'm going to put a big old angle right there. So these are the hinges. So now we're talking about the opposite sides. All right, so you know what? I should color coordinate this. All right, so this angle Q, hinge, is paired up with MP, and this hinge O is paired up with the opposite side Pn. Okay, so let's see what they tell us. In the diagram, yeah, we know that these are all equal. Great. If NP is greater than MP, okay, so they're giving us the sides again. If NP is greater than MP, okay, for example, imagine that this was 10 and this was 8. Okay, NP is greater than MP. So which must be true? Well, before I even look at the options, I know that if this blue side is bigger, then that means this blue angle is bigger. Okay, so I know that the measure of angle O is greater than the measure of angle Q. And again, that would be the converse of the hinge theorem if it comes up, because they gave us the sides and then we are figuring out something about the angles. So let's see. Segment OP is longer than segment MQ. No, it's not about that. Segment MN has the same length as segment MP. Nope, that has nothing to do with it. I'm really just looking for this. The measure of angle Q equals the measure of angle O. That's close. All right, we're talking about the right angles now, but not equal, no. Angle O is larger than angle Q. Ding, 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 that's the one that we wanted the whole time. Okay, all right, I think we're down to the last question on this little video. The lengths of the sides of the triangle are written in terms of the variable p, where p is greater than or equal to 3. And then now they're wanting us to put in order the angles, all right, from greatest to smallest. All right, because this is the greater than symbol. So it's saying A is greater than C, which is greater than B. So they want it from biggest to smallest. So what you can do is just plug in this number. It says greater than or equal to 3. Let's put in 3 and see what happens. If I plug in 3 right here for P, then that makes this 3 plus 4, so that's 7. Okay? Imagine if I plug in 3 right here, then that would give me 4 times 3 minus 1. That's 12 minus 1, so that's 11. So this would be 11. If I put in 3 right here, 3 times 3 is 9, so this would be 9. Okay? So the bigger sides are across from the bigger angles. Okay, so check it out. The side lengths in order go 11, which is bigger than 9, which is bigger than 7. All right, I've put them in order from least to greatest, just like they want for the angles. So now let's look at the angles that are across from these. So the 11 is across from angle C. So the C goes first. Okay, then let's look at the 9. The 9 is across from angle A. So A should go second. Now let's look at the 7. The 7 is across from angle B. So B should go last. So just look for this order, C, A, B. And I see it right here. So this is the order. C is greater than A, which is greater than B. Let's check it out. Kabam! And that's how it's done. I hope this video was helpful. Good luck on your quiz. I hope you took notes. Use those notes on your quiz. Good luck.